This is the last lesson in our percent application section over percent change and percent error. Percent change is the extent to which a value increases or decreases, also known as percent increase or percent decrease. Before we begin, it's really important that you understand how to change fractions to percents and be able to do that quickly. If we have 3/8, we're going to change 3/8 into a fraction or into a decimal first by doing 3 divided by 8 in our calculator. We would get 375 thousandths as our answer. To change a decimal to a percent, we move that decimal 2 places to the right and tack on the percent sign. So our final answer is 37.5%. For 12/25ths, there are a couple of options here. Percent means out of 100. So if you notice, the denominator 25 is actually a compatible number with 100, meaning it goes evenly into 100. We have to think, hey, 25 times what is 100? 25 times 4. When I multiply the bottom by 4, I multiply the numerator by 4. I would rewrite my fraction as 48 over 100. Percent means out of 100, so my answer here is 48%. This method I just showed you only works when the denominator is compatible with 100, meaning that it goes evenly into 100. So the next one is 11/200. I want you to go ahead and pause the video. Try it yourself, see if you get it right. Okay, we do 11 divided by 200 in the calculator, and we would get 55 thousandths as a decimal. It's important to remember to move that decimal 2 places to the right and tack on the percent sign for a final answer of 5.5%. Let's go ahead and practice how to find the percent change. Here we have a situation where Ashley earned $20 babysitting in January. In February, she earned $32. What is the percent change in her earnings? So I don't want to know how much more money she earned, how many more dollar bills I'd have to pay her. I want to know the percent, how much more percent-wise I'm paying her. First thing we need to do is to highlight this formula down here, difference over starting amount. You need to know that. That's important to help you figure out what you need to do. So step 1 means you need to find the difference. And in this case, I'm going to go ahead and subtract my two numbers. Oops. Sorry about that. Okay, so we're going to find the difference. I'm going to go ahead and subtract 32 minus 20. 32 minus 20 is 12. In my ratio, I'm going to set it up as difference over starting amount. So difference is 12, and sometimes it's difficult to choose which one's the starting amount. You know, do I pick the bigger number? Do I pick the smaller number? Well, you got to think about what she started off with. And in this situation, we're talking about January and February. January comes before February. So the amount of money that she earned, that $20 in January, is the starting amount. So that goes down on the denominator. We are then going to change the ratio of 12/20ths to a percent by taking 12 divided by 20 in our calculator. Always think of it as 12 divided by 20, not 20 divided by 12. When you do that, you're going to get a decimal of 6/10 that you need to move 2 places to the right. Add in that 0 for a placeholder, and you get an answer of a 60% change. Now the next part is we need to explain whether or not this is a 60% increase or a 60% decrease. Think about that for a second. What do you think? Did her money increase or did it decrease? It is a percent increase because the money she made in February was more than the money that she made in January. So go ahead and write that down, and then we will move on. Okay, just real quick, it is a % increase because she made more money in February than January. Her earnings increased over time. Make sure you copy this down before we go flip over to the next side of the page about % error. The second half of this video is talking about % error and how we use percents to help calculate those. First of all, we need to know what a % error is. A % error describes how far away from the expected value your result is. It's kind of like a bet. If you bet something, you want to know how close you're going to be or how close you actually were to what you thought was going to happen. All right, so we have the predicted temperature today was a high of 55 degrees Fahrenheit. The actual temperature was 47 degrees Fahrenheit. We need to calculate the % error. The ratio that we're going to eventually set up is difference over actual value. You'll notice it's very similar to % change, but it is different. Yes, we have the difference on top, but the bottom, instead of it being the original amount like in % change, we're actually going to write the difference over the actual value. Let's read this question again. The predicted temperature today was a high of 55 degrees Fahrenheit. Predicted means that it is a guess. It's a bet. We're betting that the temperature is going to be 55 degrees. And we all know weathermen, as much as they try, they're not always right. So we're finding the actual high temperature was 47 degrees. We're going to calculate the difference, so 55 minus 47, and we get a temperature difference of 8 degrees. So they were off on their guess by 8 degrees. We're going to write the difference over the actual value. Temperature was lower than what they guessed, so it's 47. The ratio would be 8 over 47, or 8 divided by 47. Our job is to take that ratio of 8 over 47 and change it to a %. Remember that vinculum, the fraction bar, means division. So we're going to type into our calculators 8 divided by 47, which gives us a decimal very close to 17 hundredths. We're going to move that decimal 2 places to the right, which gives us a % error of 17%. That means that we were 17% off on our guess. We were kind of close, but we were getting kind of far away. I want you to try it out. You must show your work on this. Give it your best shot. Mrs. Carmichael and I will be around to check this as part of your completion grade. You don't have this part done, and you're going to miss out on your points. That's it. Hope you learned a little bit about % change and % error. We'll practice the next time we're in class together.